Now we've got Paul Nakuloyu, all the way from Japan. I'm not sure who wins the award for the furthest travel. Works with EarthBrain, and he's going to talk about overcoming challenges in 3D GS quality, visualization on construction job sites. Give him a hand.
Thank you, thank you. Okay, you can hear me. So I work for EarthBrain. Probably some people don't know it. So EarthBrain is a joint venture between Komatsu, NTT, Sony, and what we try to do is make smart construction a reality. So we were founded in 2021, and we try to use digital technologies to digitize the construction process. So basically, this is the ecosystem that we provide. We start from a real job site that we try to solve, and then we use various tools to digitize it. And once we have digitized it, we then try to optimize the construction process, analyze the situation, and optimize it by using simulation and various other digital tools to get the best process of the construction process and then implement it into reality. And we repeat this cycle over and over again until we get a more efficient construction process. So based on that, our product stack relates to various topics like machine optimization, or various data collection to visualize and then analyze the job site, and various project management tools. And this is a stack of products that we offer as part of the digital transformation process. So one of those is site digitization. So as we have a real construction site, we usually fly drones over it, and then we use something like photogrammetry to triangulate from images where each of these points are in 3D space. And then we use this photogrammetry process to build a point cloud of the construction site, which we then use Cesium to render within our product called Dashboard. So in this case, these are point clouds in one of our test sites that we have scanned in this particular area. So you can see they're like in 3D, while this is just a regular Cesium backend. And then we use this as, then our clients can use it to do data analysis and optimization over the construction process. The problem is that point clouds are not very well suited for the human visual system because you can actually see through them all the way to the other side. And we're trying to get something that is more visually appealing for our customers. So recently, a very popular method has been this thing called 3D Gaussian Splatting, where you take points in a point cloud and stretch them out, make them nice and fat. And if you stretch them out well enough, you can actually fill in the image that the photogrammetry was based on. If you do this well enough times from enough points of view, you can actually get a pretty good 3D representation of a 3D scene. Here is an example of what this looks like. So this is a 3D Gaussian splat that we have made using drone data. A challenge is that once you get too close to a scene, you can actually start seeing these splats. And therefore, it becomes it ruins immersion in case we want to do it. The further away you get from the drone view, the less immersive it becomes. So in case this is a close-up, so you can actually see all of these splats here. So recently there have been various ways that people have tried to get over this. You can replace the Gaussian distribution with the beta distribution, or use various 2D textures, or use smooth convex planes, or just linear primitives for it. To replace the Gaussian, and then you can try to better fill in the space for it. So we have done something with the textures, where you replace the Gaussian distribution with these 2D textured planes, and then we try to update this in the job site to get a better, more immersive view of things. So these are some of the results. So on the left side is like what you'd see in a Gaussian for it's very high resolution, so you don't see the problems as well. Where in this case, the writing isn't visible on this truck, but if we do like these billboards, you can actually see the writing much better. Or also here, if you get too close, you can actually see the splats from this, but if we do these 2D texture planes, you don't see them. Yeah, sorry, the time has kind of like run out. Thank you all for your time.